Hi everyone. It's my pleasure to be here today. And today's presentation title is Boost Your AI with Quality Data. And let me tell you a bit about myself first. My name is Magda, and I work as a data evangelist at Toloka AI. My background is in artificial intelligence. This is what I have studied at Edinburgh University. And then I worked for several years as a data scientist across different industries. And recently I've been involved in teaching and mentoring other data scientists. And also I've been contributing a lot to online publications, such as Towards Data Science and Towards AI. And also, let me tell you a bit more about Toloka. So Toloka is a crowdsourcing data labeling platform that is used by high-tech businesses to quickly label large amounts of data. And then this data is used for training machine learning algorithms that lie behind many of the AI products that you probably know from your everyday life. For example, self-driving cars, computer vision systems, speech technologies such as chatbots, voice assistants, and some retail and e-commerce services as well, and many more. So this is our agenda for today. So we're going to talk a bit about data, different challenges connected to data in context of AI and machine learning. Then I'm going to tell you a bit about crowdsourcing and how crowdsourcing can help with the challenges we're going to post at the beginning. And then I want to give you some examples of data labeling pipelines. They come from different industries. So yeah, let's get started. I think it is a common knowledge that AI projects, almost all AI projects start with data. No matter how simple your idea is, you cannot really develop machine learning algorithms without some examples to train them on. At least if you use supervised learning methods that are the most popular behind AI products. And additionally, as this slide mentions, 80% of data scientists' time is spent on preparing and managing data. This chart has been published in Forbes many years ago, but I believe this is still actual. And ideally, we would have some tools and processes that would help us to reduce this number at least slightly. And as mentioned before, all AI solutions require human annotations. But we did not talk about the scale here yet. So current AI projects, especially deep learning solutions, are super data hungry and they require data labeling at large scale. The question here is how to achieve this scalable and effective process. So in general, the AI industry is based on three pillars, and those are algorithms, hardware, and data. And currently, the first two, algorithms and hardware, have become commodities. So they are easily available to any engineer, as they are a variety of public solutions that you can see here on the slides as well. But on the other side, the third pillar, data, was kind of neglected and underestimated in the last decade. And there was not many solutions developed in this area. And we believe this situation is changing now, and we can see that AI community goes more towards data-centric approaches, and there will be more tools and services focused on this aspect of AI. And one of such tools is Toloka. So what is crowdsourcing? I would like to tell you a bit more about crowdsourcing and how it can actually help with this third pillar, data and data labeling. So crowdsourcing is an approach to design business processes when you have some big task, but you decompose it into smaller parts, and then you send those smaller tasks to different performers. Every single person in a cloud makes a very small effort, but their efforts are then taken together and the requester can come up with the final solution to initial big task. And the traditional approach to data labeling was a bit different, and it usually involved a person or a group of people, um, some kind of the in-house labeling solution where either a machine learning engineer or a data scientist would sit down and just label some data. Usually it would be some small amount. So unfortunately, this approach was expensive, immeasurable, and especially hard to scale. On the other hand, crowdsourcing can be useful here because the process is usually more economical. This is because you can set your own prices and you can use workforce from different parts of the world. It's usually more scalable as you can have access to the crowd basically 24/7. And additionally, if you implement some quality control rules, the process can be also measurable and easy to manage. And when you use crowdsourcing approach, in contrast to this traditional data labeling in-house data labeling project, you change this process into managing a pipeline rather than managing a group of people. So by doing this, we turn this human management task into an engineering one. This means that your role is more focused on designing a pipeline rather than managing people. So in help comes here automatization and some quality control rules. And together, those together can basically help you with building pipelines that are effective, easy to scale, and manage. Additionally, if you want to look at this from the perspective of the performance, the traditional approach may not be also very attractive. So in this traditional setup, a performer would be required to sit long hours in small cubicles and maybe perform some boring and repetitive tasks all day long. And we believe it should be different. And crowdsourcing allows people to work from the comfort of their own home. And it allows them actually to choose the tasks that they are interested in and gives them possibilities to switch the task if they don't like them. And when we have a lot of people who do not have really strict obligations and we just require a really small effort from their side, this is when we can treat this crowd as another computing cluster. And this is when you can use some API or some mathematical methods and tools to automate the pipelines and create this scalable data labeling solutions. So this management process usually can be broken into 4 steps. And the first step is actually selecting performers for your project. So you could select them looking at different characteristics, such as language, age, gender, maybe the device they are using, etc. And then after initial selection process, we want to train the candidates that are already allowed in the project. And ideally, after the training phase, maybe we could set up some kind of a test that would allow us to test how well the performers understood your instructions. And you could also assign some kind of skill connected to this test that basically will allow you to pay better performing performers slightly more. And then in a first step, we create also some quality control rules and we're checking for human behaviors. So this would be a place where you create control tasks and maybe do some additional checks when you Maybe check if the video was played, if it was required in your task, or maybe if all the buttons that were required were selected, etc. And once you gather your responses, you need to aggregate them in some way. And this is the last step of the pipeline. And these 4 steps usually allow you to gather quality data in a timely and efficient manner. And now I would like to give you some examples from the industries. And we have efficiently designed the pipelines for different business needs. You can see a big list here of industries, but I would like to talk about some particular cases. So the first case that I would like to focus on is search relevance. So typically in search relevance, we would have already some current algorithm that is in production, but in the background, we would still try to train new models in order to improve performance of the search engine. And in the graph here, there are 3 models that are candidates to replace the current model in production. They have been trained using some training data before, but the problem is that we don't really want to show these results of those models into the public because we don't really know how well they are performing. So this is why we want to do some kind of offline evaluation. And this offline evaluation can be done by crowdsourcing. So we can create tasks that we give to a user that have search query and a proposed result, and we just ask him how relevant the result is to the query that is posted. We can do it for all the models that are candidates, and then we can compare their performance. And this way, we could eliminate the models that are performing really badly, and only the one that performance is acceptable could be left and then further sent to further human judgment. And this is when you could maybe already push those models to be seen by the public, and you could try to do some kind of A/B testing. And once we get the results of online evaluation, we could replace the current model in production with the best model from the A/B testing part. And because we use this pipeline, we use offline evaluation in the parts of this pipeline, the user was never exposed to really bad results of the initially trained algorithms. So this was an example of a pipeline that uses crowdsourcing in search relevance projects. And then we have another case, and this comes from self-driving cars industry. And so it's a classical computer vision task. And in order to train computer vision models, we need to feed it with thousands or millions of images. And usually those images have objects that are highlighted with polygons. So maybe we would have every car, every pedestrian, every traffic light highlighted with the polygons. And this is not a trivial task, how to actually produce those millions of annotations, and sometimes even on a daily basis. So how it can be done? As a final result, we need to have an image where all objects are highlighted with polygons. So what do? We should decompose the task into a set of smaller tasks. So for example, a subtask could be devoted to a specific category. For example, please highlight all the cars, or please highlight all the pedestrians, or please highlight all the traffic signs. So the big task is decomposed into smaller ones. And then we could ask a person to make just a really small effort and highlight, for example, those traffic lights in the picture. And Then we would have a second step where we would ask several people to correct if those polygons have been actually highlighted correctly. And if everything has been done correctly, those tasks accepted. If those tasks are accepted, if they are not, they would go back and get annotated again. Um, and thus, this loop would go kind of forever until we collect enough images that are annotated that way. And this is an example of such annotation. We have initial image without polygons, and on the right-hand side, we can see the result. I also have included here a drawing of a more official drawing of such a pipeline here. And you can see that the first project is just filtering if there are any objects of interest on this picture. The second project is used to do actual polygon annotation. And then we have a third project which is just checking if those annotations are correct. So this is an example from self-driving cars. And next example comes from the voice assistant problem, and it involves some audio collection. And this example actually comes from the experience of Yandex. And Yandex has its own personal voice assistant. It's called Alisa. And in order to activate a voice assistant, you need to say, "Hey, Alisa." So therefore, in order to train the algorithm to recognize different voices, they had to collect a lot of recordings of people saying a phrase, "Hey, Alisa." So this is actually the first project that was created. And then there was a second stage when they asked several people to listen to the recording with this phrase and verify if those has been done correctly, if there are any background noises or any irrelevant phrases, etc. And if everything was correct, they would accept such a project. And if not, this recording would have to be taken again. So that way, they collected enough recordings to train the voice recognition system. And the third example that I would like to show you comes from the moderation of content, and it also involves a human in the loop process. In this case, we already have a machine learning model that is in production. It's been trained to moderate content, but due to fast changing environment, this algorithm is not always confident about its predictions. And in this case, it can be aided with human labeler. And this is actually what we call a human in the loop process. So basically, if an algorithm does a prediction and it falls under a certain threshold, like low confidence level, we send it then to human annotator. This human annotator has been previously trained to moderate content, and he just gives us his own annotation. So that way, the machine learning algorithm is aided with this human annotation. And the final result is actually a consensus between the model and the human. Additionally, what can happen here is the human annotations can be further sent again to machine learning algorithm to get it trained again and basically improve its performance as well. And this was the last example that I have prepared for you today. So I just wanted to give you a short summary of what we have been talking about. So at the beginning, I have showed you some challenges connected with data, and we saw how data is currently a bottleneck to many of AI solutions. I have told you then how crowdsourcing could be an effective way to gather quality data. And then I gave you some examples of data labeling pipelines for 4 different industries. So I hope you liked it, and if you did, you can try our crowdsourcing platform, Toloka. There is a promo code here. It's called Toloka Tech. Also, if you want to try crowdsourcing, you can join our community. And if you have any questions regarding data-centric AI, crowdsourcing, or Toloka, please reach me there. You can use this QR code to join our Slack channel. And I think that would be it. Thank you very much for listening. And yeah, I hope you enjoyed it.